On this video I've got two motherboards which are identical, and one works and one's faulty. And the faulty one's got a rather unusual problem with it, as you'll see as you watch through the video. And I kind of debate how I can actually diagnose this problem as to what's going on, and I'll come up with rather an interesting solution, I think. So hope you watch the whole video, and I'd like to hear your thoughts at the end and see what you think. Okay, so here we go. I hope you enjoy this one. I've got a couple of Gigabyte motherboards here, which came from computers I got at the flea market on Sunday at the weekend, yeah. And this one had an i7-4790 in, and this one's working, apart from I had some problem with the contacts on the DVI. There seems to be a lot of dust and dirt. In fact, these were filthy, both of them, yeah, very dirty. So apart from that and the wire with it, I got a good contact then. I had this loaded into Windows. I haven't loaded all the drivers, but it does boot into Windows and run specking. It said everything was okay. So that one I'm sure is actually a good board, yeah. The other one is stuck in some sort of boot loop, so it kind of like the fan comes on, spins for some seconds, goes off, powers on, some seconds, powers off, continually in a loop. And one cause I've seen for this recently has been corrupted BIOSes on Gigabyte motherboards. And normally they have like a main BIOS and a backup, but these only seem to have a main BIOS. I'm not sure these even have the two BIOS, but even the ones in the main and the backup, I've seen them, they don't seem to be that reliable. They get corrupted and you have to take off the BIOS chips and reprogram them with an EEPROM programmer basically, and then they work. So I've done that quite a few times and it's worked. And last week or the week before I had one which it didn't work, and it turned out to be the CPU, and that was another of the same ones, i54460, which I have here, which is a faulty CPU. And I proved that by using a known good i3. So I stuck the known good i3 into here and it didn't work, it's still stuck in the boot loop. So that video is really a look at what we got at the market and like a triage. I didn't do any repair, so I haven't looked any further at this one. But yesterday I put both of these in the sink with soap and water and a soft paintbrush, yeah, and I cleaned all the dirt off them really. So these are much cleaner now, both sides, yeah. So we're ready now to test this one again, yeah, and see if it's still not working. I've got the other one which I can hopefully use as a comparison between the two if we need to do that. So let's put our known good CPU on this one, and we'll leave it without RAM and see if it bleeps when it boots up, yeah, and then we'll take it from there. This didn't have any shorts on the 12 volt last time I tested, but as soon as it's been in the sink we'll just test it again. That's okay, these two are the ground ends, yeah, so that's okay. So there's still no shorts, which I mean I wouldn't have expected it to be. It was okay before. We'll put the 12 volts on that then, and there we go. We'll use our fan that we use for diagnosing, the one that we just balance on to the board. So these legs are too short to actually reach the board, so it's quite useful for this. Yeah, it sits on there quite nicely. Okay, so we can power this up, and let's see if it actually bleeps now. Oh, CMOS battery. One thing I forgot, yeah, some CMOS battery. Obviously I took the CMOS out when I put it in the sink. That's a good idea, by the way, yeah. That's a good idea. When you put it in the sink, take the CMOS battery out first, yeah. Always advisable. Actually, while we've got this one, let's just check to see what current has been drawn from the CMOS, because this is often a good indication if the real-time clock RTC is actually running. So we're expecting a couple of microamps or so. It does vary, but certainly less than 10 microamps, yeah. Let's see what we've got. Oops, I'm doing it wrong. One on the battery, set to microamps range, and then we push the little clip back, yeah. And we're reading 1.69 microamps, which is perfectly fine, yeah. So that didn't tell us anything. But anyway, it's good because it told us the real-time clock's almost certainly running. Yeah, let's then power this up and let's see what it does now. Does it bleep after it's had a after it's had a good clean? Yeah. Fan comes on and it stops it. Oh, power's on again. Yeah, it's kind of stuck in this like loop where the fan's powering on and off over and over again. Yeah. This is basically what it was doing before. CPU's cold. You can see the fan there. CPU's cold, which makes me think probably there's no V-core. Yeah. So that's the first thing we can check. Has it got any V-core? Easiest place to check is on these inductors if we just turn it upside down. Well, the other way is to check on the MOSFET. So there's a pair of MOSFETs in the capacitor there. That's one phase, and this is another phase. Yeah, this is a different supply. Yeah, this is cold. So I'd say we haven't got any V-core. I'll just zoom down, and then we'll make some measurements. Okay, we've got the meter where you can see it's on volts range. Yeah. So as I say, one place to check is just on the inductor coils by turning it upside down. But the other place you can check is on these MOSFETs. So one side will effectively be source, the other side will be drain, and one of the pins will be a gate. Yeah. So if we go on one of the middle pair here, we know it's not going to be the gate, and one side will be 12 volts. Let's see if is it this side. Well, that's interesting because the power supply is switching on and off. Yeah. Well, that's interesting because the power supply seems to be switching on and off. So let's go over to the ATX connector and see what's happening with the other voltage rails. I'm guessing they're going to be doing the same. So this is the 3.3 volts. And it's powering on and off. Red will be 5 volts. Powering on and off. Yellow, 12 volts. Powering on and off. Purple is a standby. I'm guessing this is there all the time. Yeah, that should be there all the time. Okay. And then green is a signal which tells it to switch on. So if green has got 3.3 or 5 volts on, this is 5, it's switched off. And when this goes to 0, it should start. But this is going to 0, then back up to 5. So the motherboard is signalling the power supply, telling it to switch off. That's what it's actually doing. Okay, I'll just switch the main power off. Let's probably spin once more while the power supply discharges. Nah, it's done. I don't think that's happening because there's any sort of overload anywhere. I think that's happening because for some reason the motherboard's telling it to shut back down. But what we can do is we can just compare with the known good board and just check the resistances on all the main voltage supplies, and let's see if there's any difference. Personally, I don't think there will be. I've just gone to ohms range then, and I just want to have a look. So I'll just find the ground point on the board. I've just got this bytes and see what is width. So the first two are 3.3, yeah, and they're reading 12 ohms. Okay. Fourth one in is one of the 5s, 2.1 kilo ohms. And the second one in from this end is 12. What's that reading? It's kind of like a falling voltage. Sorry, falling resistance. But then it's going back up again. Okay. So that's like a capacitor discharge, then it's recharging. So that's on that one. So we can also just check on here, but I think it's just read high. Let's just see. Again, the rising. This is just capacitor discharging and charging, yeah. So at least we can see what it's doing. Let's have a look at the other one. There's no shorts, that's what I was looking for, really. Okay, so on this one, yeah, same sort of thing, yeah. 3.3 volts. Sorry, just off the edge of the picture. 3.3 was about 12 ohms, yeah. 1, 2, 3, fourth one in is a 5 volt. 2.7, yeah, basically the same. And second one in here, we get this kind of like what we had before, yeah. So that's fine. And then it starts going up again, yeah. Okay. So there's no difference there. It appears to me that basically this one is signalling the power supply to switch off and on. somewhere with the logic, the PCH almost certainly is sending the signal to there. Yeah. I guess we could just check vCore, because I couldn't see. I think this wasn't getting out at all. So we take the CPU out, because that will be quite a low resistance, and then we can flick the board over and just have a look to see what's on vCore to ground. Yeah. So we go over here. Let's have a quick look at what we've got. So from the inductor coils which are here to ground, I'm guessing that's a good ground. It's in the kilo ohms range, so there's no short there. And we can just look on. Oops. We can disconnect the fan, and we can just look on the other one. But I'm sure it'll be just exactly the same. Yeah. Put it over here. Okay, so again, one of these inductor coils to ground that without a process, we expect it to be quite high. Oh, is that reading different? No, I just didn't have a good ground, and something's charged up on this, so I'm reading a negative voltage. Yeah. Let's go back to the other one again. Okay, I had a little bit of charge in the vCore capacitors basically, which is why when I see like negative resistance readings, that's what it is. Yeah, so I'll just discharge it, and then we'll go from ground to the coil. Yeah, well, you can see what it's doing. It's reading kilo ohms and climbing. Yeah, that's the good board. Let's look at the one that's powering on and off. Yeah, which is the bad one. Yeah, this is the one. So again, we'll just make sure the main vCore capacitors are discharged, and then we'll go to here. Yeah. Yeah, it's doing exactly the same as the other one. So there's no resistance problems. I don't think we've got a situation where something's drawing current and shutting down. Something the logic's telling us to shut down. Yeah. Which is probably going to involve the PCH and the SIO. These two chips going to be involved. Yeah. I think the first thing we'll do now with this one is we'll reprogram the BIOS just to eliminate the possibility that we have a corrupted BIOS doing this. I've shown this done before, so I'll just do like a very quick version on the video this time. Okay. First thing I'm going to do is unsolder the chip. A lot of these boards have an M BIOS and B BIOS, main and backup, but I've just looked all over this board, both sides, and I cannot see a B BIOS. It's generally right next to the M BIOS, so I really don't think there is one. So first thing we'll do is we'll get some flux, and we'll unsolder this chip. So easiest way to do this I've found is normal leaded solder. You get a big blob of solder that sit right across the pins of the BIOS chip. Yeah, both sides. Okay. This will form an alloy with the lead-free solder. There you are. So that is now going across both sides. Yeah. You'll now find that with a pair of tweezers and the hot air set, I have it set at 450. Just there we are. Yeah. 450 and full blast. And this will melt now before anything around it melts. So you haven't got to worry about nearby components. Yeah, this is going to melt first. Get heat in towards it. It'll come off quite shortly. Yeah, like that. Yeah. Just be careful if you do it this way. You don't get a blob of solder landing back on the board, yeah, because you put a lot of solder. Obviously, while this is still hot, it's a perfectly good opportunity to just clean that up now where you've taken it from. Yeah, there you go. So that's how to unsolder it. Now I'm going to actually solder it onto the adapter built into the BIOS programming. The best place to get a BIOS is the manufacturer's website. Yeah. So this is Gigabyte's website. I just googled for the model number plus BIOS. Just make sure you get the right links, because you find people putting like fake websites, you know, like support.gigabytex.com and stuff. Yeah, just make sure you're actually on Gigabyte's website. I'd recommend that. Yeah, and into the support downloads. Make sure it's the right revision. My board's definitely revision 1, it says on the board. Yeah, I'll just show you that in a minute. And I've just got the latest BIOS. I unzipped that into a folder, and I've got the flash utility, obviously of no use to me, and I have this F2 file. Sometimes it's a bin, sometimes it's a ROM file, but if it's a round number like this one's 4 megabytes, you can be pretty sure that is the file you want. Yeah. So we've got that. So now basically we need to actually program that into the chip. Yeah. So this is the chip soldered onto the little adapter. Yeah, make sure it's the right way round. So it has the dot towards that little notch there. Shows you here which way the board goes in up here. Yeah. So like this obviously matches this. This is you've seen it before, I'm sure, a TL866A. Yeah. I need to get the later model, the CS2, to program 1.8. Well, BIOS is now doing more graphics cards, but this is good for any motherboards and a lot of graphics cards at 3.3 as well, I found. Yeah, so it's very useful for programming a lot of things. Okay, so let's program it. So to program it, you need to know what the type of the chip is. Yeah. So you select it. This is a 25L 3206 E. That's the actual chip. Yeah. SOP 8 is the right pin out. If you're not sure which pin out it is, I mean these three are all 8 pin. Yeah, this is 16 pin. So we know it's one of the 8 pins. If you're not sure which one it is, just go and Google for that pin out and see if it looks like your chip. Yeah, just put that plus IC package or something like that. Yeah, and see if it actually matches your chip. But anyway, I'm pretty sure this is the right one, and we'll soon find out actually, because if I now tell it to read, which is this, or read, it'll check the ID of the chip, and it says it's okay. So you can see it's now, the orange lights come on the program, it's now reading it. Yeah. I'll just pause that a moment while it does it. Okay, it's just about there now. So let's see, it should say read successful or something like that, or okay. Yeah, read finished, it's quite happy with that. So what we can now do with that is we can save that as the original file. Yeah. So let's just find the right processor. Sorry, that processor. Right folder. Yeah. This one. No, not this one. It was the other one. Sorry, my mistake. This one. Okay. And we can just call it original or something like that. Yeah, orig. And you'll see this is a bin file. Yeah. And we can save that. And now we can load the new one. You can have a quick look in here, by the way. You'll just see lots of gobbledygook. And then towards the end you might see some text you can actually read quite often. Yeah. Sometimes there's actually readable bits of words in this. Not always. Sometimes you find whole chunks which are FF like this. Yeah. This is quite normal. Don't think that's like a corrupted chunk of the BIOS. Yeah. If you see that in, it's quite normal. So file, open. This is the same folder, and this is the F2 file. Yeah, that's the one we've just saved. But we can open that with this. Yeah. Okay. And it probably will just look like gobbledygook again. Yeah. I mean, you could use like a hex editor to see if you can see any difference between the two, but I'm not too worried about it. I'm just going to program it with this. Yeah. Let's see if it works. So P for program and program. It's recognise the chip. It's now erasing the chip. Once it's erased the chip, it will program the chip, and once it's programmed the chip, it will verify or validate the contents. Yeah. So this can take a little while, and we'll pause the video. So this is almost completed now. Yeah. Just finished the verify. That's done. Yeah. So it's verified it, and it's programmed successful. So that's now done, and we can now basically put our BIOS back onto our motherboard. Yeah. And now let's see what happens. There's our BIOS chip then, quite neatly soldered back on the board. Yeah, hardly even notice it had been taken off. So the little dot at this end to the little notch at this end, there's no backup BIOS that I can see on this motherboard. So let's see if this actually made any difference at all. Let's try it then and see what happens. So it's all connected up. I've got the bleep on, there's no RAM in it. Let's see what happens now. I've turned this other up so you can see the CPU fan as well, because this was shutting down before. And it comes on and shuts down, and comes on and shuts down. Yeah, so he's basically signaling the power supply to switch on and off. Just switch that off. Let's see what happens if we disconnect the 12 volts. But there was no shorts. But let's just do it. Let's try it again. Okay, so power on. And the same thing. No bleeps, powering on and off. I wonder what happens if we just force it to power up, you know. So effectively we'll just connect the green wire to ground, yeah. Stick a meter lead in there. Then we'll just ground it, yeah. And let's see what that does then, yeah. We'll let it start up and ground it. It still shuts down. And it stays off. Oh, that's strange. That's like effectively the power supply is like tripping out, but there's no shorts. Okay, I've taken my wire back off again. This is like this power supply effectively is tripping out. So the power supply trips out, and then obviously all the power goes off. So this will, apart from the 5 volt standby which stays on, so this will go high again, and then it gets stuck in this loop. I mean, to prove that point, and this is without the 12 volts connected on here as well, so it's something off here. To prove that point, let me just get the other known good board, and we'll see what happens if we force that one to run. It should stay on basically, yeah. Okay, this is the good board. I've put the same CPU on this one. So we'll power this up, and this has got RAM in, so this should power up, stay on, and bleep once. I've got no monitor attached, but yeah, I got one bleep there. So that powers on and stays on, yeah. Now let's take the RAM out. This is the one that had no RAM in, yeah. And let's see what it does now. So that's without the RAM. Again, power on. Bleeping. But it stays powered on, yeah, just bleeping. Right, so what will happen now if we take off the 12 volts like I did on the other one? Yeah, we'll take this off, yeah. What's it do now? So I'm expecting it will just power on and not bleep. No, it powers on and off now. Maybe these act like that when there's no 12 volts. Put the 12 volts back on. Power. Powers on, stays on, and bleeps, yeah? Okay, let's do the same with our board now. In the same, so no RAM with the 12 volts connected, yeah? Right, so this is exactly the same as the other one. No RAM, 12 volts connected, yeah? Powers on, powers off. Now, that I can accept it doing that, yeah, because there's something wrong with it. And if we measure like we did before, from ground to the green wire, this is going to 5 volts then to ground, yeah? Yeah? But if I ground that green wire, this should come on and stay on, and this is what I don't understand. Ground the green wire, yeah, and connect it to ground, and this should come on and stay on. And it comes on, and then just stops. And that's as though it's something like tripping out in the power supply, if you see what I mean. I mean, if I now measure the voltage on the green wire with the power supply as it was, it stays low, yeah, something's in here is holding that low. The 5 volt standby is there. Sorry, I've got the meter where you can't see it. Yeah, 5 volt standby is there, but this is now low. Something's holding that low, so that means the power supply should be on and it's off. Yeah, that's why it doesn't make sense. Switch it back off. That's going to stay there. No, it may sort of go away like it's been released. Yeah, switch it back on now, and this is at 5 volts as you'd expect. And it goes back into this cycle again. So every time it goes low, the power supply starts and shuts off. That's interesting. That's to me like when I ground this, this should come on and stay on, and this stays grounded, so this should stay on, but it doesn't. And this makes me think that this is, well, I say think, this is tripping out. Something's causing this to trip off and stay off when we do it that way. That's interesting. I'll go across all the board and I'll measure all the coils and I'll measure all these voltage regulators on this one and compare on resistance mode, yeah, and compare them with the other board and see if I can see like a short, maybe like a short not on the 3.3, the 5 or the 12, because you know they're okay, but a short like on a lower voltage rail generated from one of these, yeah, that might cause it to trip out. That makes some sense. Okay, let me have a look. Okay, I've done that. I mean, I've checked all of the regulators I can see and all the coils. There's some more down here, obviously to do with the RAM, and there's this one here I don't think I checked before. There's a number of these, either FETs or voltage regulators, LDOs. So I've checked them all, there's no difference. So I can't understand what's causing the power supply to shut down and stay shut down when this has still got 0 volts on it. Unless there's obviously something internal on the power supply that sensing an overcurrent, I'm guessing, something like that, and it doesn't like it and it shuts down. So I could do with seeing if I could work out how to see what current is flowing on the various voltage rails. This makes me think, I mean, back in the day when I used to work in industrial electronics, we'd be faced with problems like this, and we'd quite often like, a bit like the A-team, how we build something that we could use to test it with, and I've got an idea of how to do it. And what I'm thinking, is it possible to power this? I've got a couple of bench power supplies here. I've got technically 3 because one's dual and one's a single, and I'm wondering, is it possible to power the board from a bench power supply and effectively make it switch on when the green wire is grounded, and then on the bench power supply I can see the current being drawn on each voltage rail, and I can also set them to trip out, you know, like a current limit. Let me have a think. See you soon, guys. Let me have a think about that. Right, so I've had to think about it. Yeah, I think I can do this. So this is an old ATX power supply. It does work. It actually has a bulge capacitor over here, but I'm not too bothered about that at the moment. It works. And I've got the bench power supplies, so I can actually send 12 volts, 3.3 and 5 volts into this lot effectively from my bench power supply. And I'm thinking I can use this just to generate the -12, because I don't have that from the bench power supply, and to do the bit with the standby, the 5 volt standby, and then this green wire, when it grounds, it switches on, so it switches the -12 on. And a bit of a dicky card, yeah, and a bit of thinking about it, I figured I could use a couple of relays. I've just been through my stash of stuff. I found some 12 volt relays. I've found couple of FETs. I mean, I've got, you know, lots of stuff lying around. So if I make a circuit like this, I thought, so effectively this is where the green wire comes in, yeah, which can either be 5 volts or ground, yeah. And when it's 5 volts, this FET turns on, yeah, which effectively shorts the gate of this one to ground and turns this one off, yeah. So the relays which are here are switched off, yeah, 2 relays. And then when I ground this one, yeah, so you effectively the green when you ground it, this will turn off, and this 10k resistor will pull the gate of this one up, and this will switch on, and the relays will switch on. And then coming into the relay, I can feed in the 12 volts, the 5 volts, and the 3.3 volts. Sorry for me, yeah. So coming in, I can feed in from my bench power supplies, the 2 of them, the voltages. And when the relays close, they go out to the ATX connector, yeah, together with the -12 from the thing, and the standby is already there. So that's what I thought. Obviously, so sense in would switch this, and sense in, that's the existing green wire on the ATX power supply, and this generates the -12. That's what I'm thinking. If you connect the grounds together, then that'll work, you know. That's what I thought. So anyway, what I've done is I've actually basically put this together on my bit of breadboard, yeah. I redrew the circuit because it was a bit messy, so it's basically what I've just shown. This is what I've got, yeah. So I've got 2 relays. I put reversed diodes across, and this is stop back EMF. You do this with relays, so I've seen other people do it, so I've done the same, yeah. The 2 MOSFETs, these are the ones I used for no better reason. In fact, that's what I've got, yeah. This is a 2 amp. There's more than enough of these relays. I mean, they don't draw much power. There's the 10k resistor, and the 1k goes to the green wire, yeah. So I've built that on this here, and this brown wire here, this is this sense input, yeah. So I've got it switched on. The white one, this is going to the 5 volts on my bench power supply. This is the 12 volts on the bench power supply, and then this is ground, yeah. And this green wire, this is ground. So when I ground this, nothing will happen. There's no lights on, but you should hear the relays click. Yeah, you can hear them, I'm sure. Yeah. So that's working. So what I'm going to do is now I'm going to put this circuit together on a bit of Vero board, yeah. I'm going to cut or solder to the board one way or the other. Some thick wires going to the relays. I'll disconnect this lot. Under here I might just cut the tracks, yeah, to disconnect them, and then solder in, you know, the 3 wires coming from the relays. And on the back of here I've got some of these. They're a bit messy, mixture of new ones and used ones, yeah, but I've got some of these I can stick on the back. That's what I've got, where I can feed in the 3 voltages, yeah, and a couple there ground terminals, one going to each power supply, yeah. That's it. So I'll stick this together, and actually if this works, these will be on the back, the connectors, yeah. This thing will fit inside here. I can put the lid back on. I don't think I need the fan because I'm not taking any power from this anymore, only the -12, that's almost nothing. And that's why I'm not too worried about that capacity, yeah. So okay, let me do it. I'll stick it together in here. Let's see if this crazy plan actually works, and B, if we can then tell anything useful from it from the bench power supplies, because it's got current meters on, yeah. Well, it's all coming together quite nicely, I think. This blue wire is soldered to where all the black ones are here, yes, that's the ground. And you can see I've cut off the yellow and red and orange and put them into these terminal blocks here, yeah. So these are going out to all the power rails. I've made this, so this can go on the front here. Yeah, just drilled it, and I've drilled some holes to mount it. So this can go on here, yeah. That's where the power is going to come in from the bench power supplies. This is my little circuit that I had on the breadboard. I've now wired it up on Vero board. I've tested this, so I've marked these. So the yellow and green, but we'll call them yellow. That's your 12 volts, yeah, in and out, and the same for the other ones, the orange and the red, yeah, in and out. So I've connected all them up, and I've tested this then on the bench. So the green wire, when I ground this, the relay's closed, yeah, so I know it works. This, I've drilled a couple holes in the back of it, and I'm going to mount this onto the top of the heatsink here, yeah. Postman arrived, stuff from AliExpress, so it's interesting. Yes, I'm going to mount this onto this heatsink here, because this is like the low voltage side. Yeah, this is just the rectifiers. But I'm going to put a bit of this plastic down here in between, just to stop anything on the back of here shorting to the heatsink. Yeah, and I've done the same here with a bit of plastic over the power comes in. Yeah, so this board will mount onto here. It'll be nice and safe, and then all I need to do is connect these wires to the outputs and to the inputs on the connectors. Yeah, so I'll get and do that, then you can see what it looks like when it's done. And that's the finished item then. Put a little label on the back of it underneath the plastic. I thought it was a nice touch. This is just off an old LCD monitor or a small TV, a scrap one. I took a big sheet of this stuff out of one. And I've just basically fastened all the wires across here. So these are effectively coming from your inputs from your power supply, bench power supply. I run out of these things, and I was struggling to get these into one anyway. So I've actually bolted all the grounds together, and this is the black ground that goes to this board. And then I've fastened it onto here with a cable tie loop, so it can't go anywhere. Yeah, it can't short or anything. And that's it, ready to go. So what we'll do is now we'll connect the bench power supplies. We'll power the ATX up, and we can start it by grounding the green wire here. And I'm just going to check that all the voltages are present. If they are, then we can put our analyzer on and see what that thinks of it as well. Okay, so let's do that. It's all set up then. So both the power supplies are on. So we've got 5 volts, 3.3 volts and 12. I put the 12 on this one because this is a 5 amp supply. I'm expecting the 12 volts to require the most current. Yeah, both the 3.3 and the 5 can supply 3 amps each, so I'm hoping that's going to be enough for just a motherboard. You know, if it's not loading into Windows, it's just basically to power it. Yeah, so I'm on the black wire here, and we can see that the purple wire, this is from the power supply, yeah, the ATX power supply. So I've got 5 volts standby. The green wire's got 5 volts on it, yeah, and then everything else is 0. So we can go to one of the red, and that's 0. We can go to the orange at the other end, and that's 0. And we can go to a 12, yeah, and that's 0. I also know it's 0 because this is drawing 0 amps, and when the relays are on, it draws 80 milliamps, yeah. So what we can do is now we can take a lead. I'll just find suitable lead. Yeah, this should do, hopefully. And we can ground the green wire if this will fit in it, otherwise I'll use something else. Yeah, will this fit in here? No, it won't. Okay, let me just find something to ground the green wire with. Okay, so I've used one of my favourite things. It's actually a 22 ohm resistor, but it's low enough to ground it, and it's just a stiff bit of wire really. Yeah. So we can now see the 0 volts on here. I know it's working because this now says 80 milliamps, yeah. So now we should have, hopefully, have all the supplies coming through to here. Yeah, so there's 5 volts on the red. There's 3.2 volts, 3.3, 3.27. It's close enough on the orange, yeah. And yellow, it's 12 volts, yeah. We can also look on here as well. And yellow is 12 volts, yeah. So that's triggered it. And obviously, if I take this back off, it'll switch off again, yeah. You can see it. So that's working. So what we can do is now, I didn't bother to check the minus 12 actually. I'm sure the minus 12's there. If the ATX is, you know, switching, I'm sure it is. So yeah, I suppose I ought to check that though. One moment. Okay, I actually just connected the ATX analyzer. So you can see the minus 12 is minus 11.6. Yeah. All the voltages are there and stable, all very stable. So what we'll do is now we'll try this on the motherboard. I'll just find something that isn't of any value, like a 775 board, and let's see what happens if we try to power a motherboard up off this now off our bench power supplies. Well, everything's ready to go, so we can just push the power button, and you can watch the power supply readings, or you can watch the fan, see what happens. Yeah, so let's try it. Ah, what's happening is, and I just saw it. Yeah, no point any further. What's happening is this can't handle it. So the 3.3 is drawing more than 3 amps basically. I can see the constant current thing is flashing. Yeah, to say that it's dropping the voltage and it's clicking. This is why this started and stopped. I can just stick this onto a normal power supply as well, but I can't really measure the current. I mean, I know the board works anyway. So that wasn't exactly totally successful. Not the idea, but the power supply isn't powerful enough. Obviously then I need another way to test that faulty motherboard. I was hoping this was going to work so I could effectively prove, you know, which rail was drawing more current if I compared it with the working board. But this method is, well, I think the method's good actually. I think the plan is good and the project is good, but the dual bench power supply doesn't have enough warmth to supply the current needed. I probably could do with getting my hands on like a 10 amp supply or something. I can use the dual one in parallel to provide 6 amps, you know, like you can use as a single voltage rail at 6 amps. So if I get my hands on another bench power supply, I've been thinking of buying a 10 amp one anyway. I'll come back and I'll try this project again because I think it's interesting, and I hope some of you guys think it's interesting as well. Yeah. So now we need to figure out how we're going to test the original board we had. Why does the power supply shut down when I force it to start, even though I could not see any short circuits on any of the outputs? Yeah, that's an interesting question. So let's get this video posted and let's see what you guys think of this project, and also what are your suggestions as to why that faulty motherboard is behaving in the way it is. Okay guys, it's the weekend, it's the flea market on Sunday. I'll be back on Monday, hopefully with some more interesting fun stuff to do, and maybe we'll have some ideas of how to proceed with this particular repair until I can get this project running. Okay guys, see you now, ciao.